Welcome to a video of the proof of the sum of the interior angles of a triangle is 180 degrees. This is also called the triangular sum theorem. This proof is going to be based upon having two parallel lines with triangle ABC as we see here. So let's talk about our strategy before we write the proof. Since line AD is parallel to line BC and we have two transversals, angle 1 and angle 4 would be alternate interior angles, and therefore they would be congruent. So the measure of angle 1 is equal to the measure of angle 4, and the measure of angle 5 would be equal to the measure of angle 2. Notice angles 4, 3, and 5 together form a straight angle that would have a measure of 180 degrees. So if we can show the sum of these three angles is equal to 180 degrees, and we know the measure of angle 4 is equal to the measure of angle 1, and the measure of angle 5 is equal to the measure of angle 2, we can perform a substitution to show the sum of the measures of angles 1, 2, and 3 will be equal to 180 degrees. Now there are a couple other minor details we'll have to address, but that's the main idea behind the proof. So let's go ahead and get started. So again, here we have the same diagram as on the previous screen, just a little bit smaller. So of course we'll start with the given. We have a triangle ABC with line AD parallel to line BC. Next we'll state angle 4 is congruent to angle 1 and angle 5 is congruent to angle 2. And the reason would be the alternate interior angles theorem. And since these angles are congruent, we know their measures would be equal. So the measure of angle 4 is equal to the measure of angle 1, and the measure of angle 5 is equal to the measure of angle 2. This is by definition of congruent angles. Now in order to show that the sum of the measure of angles 4, 3, and 5 is 180 degrees, we're going to have to use the linear pair postulate. So now we're going to say that the measure of angle 4 plus the measure of angle BAD, notice angles 3 and 5 form angle BAD, is equal to 180 degrees. And this is by the linear pair postulate. Now our ultimate goal is to replace the measure of angle BAD with the measure of angle 3 plus the measure of angle 5. But we'll first have to state that the measure of angle 3 plus the measure of angle 5 is equal to the measure of angle BAD. And the reason for this is the angle addition postulate. Now we can replace the measure of angle BAD with the measure of angle 3 plus the measure of angle 5 using substitution. So the measure of angle 4 plus the measure of angle 3 plus the measure of angle 5 is equal to 180 degrees. And the reason is the substitution property. Now I think we have it. If we go back up to step 3, notice that the measure of angle 4 is equal to the measure of angle 1. So by performing substitution, we'd have the measure of angle 1 plus the measure of angle 3. Then we can replace the measure of angle 5 with the measure of angle 2. And this is what we're trying to prove. And the justification for this last step was the same as the reason for number 6, the substitution property. And that's going to do it for this video. I hope you found it helpful.